Video we have discussed about structural isomerism and I gave one homework to you. So the question is pentane. In both linear chain and branch chain you have to solve, I told you. So first linear chain. Pent in the sense 5 carbon. So here I have given 5 carbon. 1, 2, 3, 4, 5 carbon I have given. So carbon must balance 4 valency and combined with the hydrogen. First carbon consists of 4 valency and combined with 3 hydrogen. Second carbon is also having 4 valency and combined with 2 hydrogen. Third carbon is also having 4 valency and combined with 2 hydrogen. Fourth carbon is consists of 4 valency combined with 2 hydrogen. Fifth carbon is consists of 4 valency combined with 3 hydrogen. So this first example is in a basic manner of linear chain. So that's why I have named it as linear chain. The structure is named as pentane because in between carbon atoms we are having only single bond. Single bond I told you A and E will come. So 5 carbon atoms, pent will be the prefix. So if we combine both means they will get the answer as pentane for this structure. Next branched chain, the same formula but it consists of a branch. First in the top I have given 4 carbon, at the bottom I have given 1 carbon. So totally we are having 5 carbon. 5 in the sense pent. In between carbon we are having single bond. So single bond in the sense the suffix will be ANE. So pent plus ANE will get a organic compound name as pentane. So here from the top carbon another carbon is coming like a branch. That's why this structure is called as branched chain. So this is the answer for the pentane organic compound. Welcome back to our channel Aalam International School CBSE. Today we are going to see the topic homologous series. Homologous series in the sense it consists of general formula and same functional group which differs by CH2 group of compound. So that means this homologous series consists of same general formula. If you take any organic compound that consists of a general formula, from that general formula our remaining examples will be followed. That organic compound will have one of the functional group also. So from that definition we are going to see some of the examples. So here I have listed only 3 from it consists of more examples. Here I am going to explain only 3 examples. First class of alkane, next example is class of alkene, next example is class of alcohol. So in the first column, in the class of alkane, already we have discussed about alkane, alkene and alkyne in the previous video. Here I have taken alkane. Alkane has a general formula. From that general formula, an organic compound is derived. The first organic compound is methane. The methane has a molecular formula CH4. Next, ethane has a molecular formula C2H6. Next, propane has a molecular formula C3H8. So, as the definition says, it has the same general formula. So, from the general formula only, the organic compound is derived. So, that's why it is called as homologous series. So, again telling same general formula and it has the same functional group. That's why we call it as a homologous series. Homo in the sense, it consists of the same features. So, next example, class of alkene. The first class is ethane. I took as example as ethene. Ethene has a molecular formula C2H4. Next example, propene. Propene has a molecular formula C3H6. Butane has a molecular formula C4H8. In this class, this alkene is also having a general formula. From that general formula, we have created a organic compounds with the use of that general formula. So third example is class of alcohol. Alcohol is also having a formula, then it has a functional group. From that functional group only these examples we are derived. So how to name the organic compound I told you in the previous video. So first class of alcohol is methanol. So methanol has a molecular formula CH3OH. This OH represents the functional group. So look at the examples, all organic compound consist of a OH group. So this OH represents the functional group. So CH3OH, name it as methanol. Next ethanol, CH3CH2OH. So next propanol has the formula CH3CH2CH2OH. So overall what the homologous series is trying to say is it has a general formula. From that general formula only the class is derived. So which means it has the same general formula which consists of functional groups. Functional group is alcohol has a OH group, that is called functional group. For alkane, it has not having a functional group. Alkane is also not having functional group. From the alcohol, aldehydes, ketones, these features we have discussed in the previous video. So alcohol has a functional group. So that is also listed in the definition of homologous series. Next, we are going to see about the characteristics. So in homologous series, what are the characteristics we are having? The first characteristics, as I told in the definition, it has the same general formula and a functional group. So general formula in the sense for alkene, alkane and alkyne, I discussed a general formula like a CN H2N plus 2. It is a general formula for alkane. So like that, alkene is also having a general formula. So first characteristic in the homologous series is same general formula and same functional group. Second characteristics in the, it has the same chemical properties but different physical properties. So in this example, this first column will have the same chemical properties or same physical properties, but it not other it should not compare with the other class of alkene, because we are grouping into one class. For example, methane, ethane and propane, it will have a same chemical properties, but it will differ from physical properties. Physical properties in the sense it will differ from that size, shape, like that it will differ for each class. Chemical property in the sense it will have a same melting point, boiling point it will have. So that only I have given here in second characteristics. Same chemical formula but different physical properties. Third, difference of CH2 between successive member. So the third characteristics represents a difference. Difference in the sense we have to subtract. So from methane to ethane, if you subtract this molecular formula, our answer will be CH2. Look at here. Here CH4, here C2H6. A C here is 1 and here is C2. From C2, if you minus 1 C, we will get one more C. From H6, if you minus, we will get H2. CH4 minus C2H6. From C2 minus C, we will get one more C. From H6 to H4, if you minus, we will get CH2. This is the difference between the successive of the class of alkane. If we difference the one class from the another class, we will get the group called CH2. Again, if we difference from propane to ethane, we will also get the same CH2. So that only I have discussed here in the characteristics. So difference of CH2 between successive member. From methane to ethane, if we have a difference, we will have a CH2. From ethane to propane, if you difference the molecular formula, we will get CH2. From propane to butane, if you difference, we will get a molecular formula as CH2. So that is the third characteristics of the homologous series. So again, I am repeating the characteristics. It has the same general formula and same functional group, same chemical properties but different physical properties. Then third point is it has a difference of CH2 between from the successive members. So this is the characteristics of homologous series. So next we are moving into the uses of homologous series. We have to know where the homologous series are applied in our real life. So in our real life, I have taken two examples. One is butane and another one is ethane. We have lots of examples and lots of organic compounds we are using in our day-to-day life. In that I have taken only two. Butane. This butane is used in the lighters and portable stoves. So butane is one of the organic compounds. So we are using it in a fuel for lighters. We are having lighters. In that lighter, how that fuel is coming? With the help of this butane organic compound in the portable stove also. So second point, LPG cooking gas. We are using our LPG gas cylinder for our cooking purpose. In that LPG cylinder, one of the main compound is butane gas. With that butane gas, propane also mixed. From these both coming together, combined, and we are using our cooking LPG gas. LPG stands for liquefied petroleum gas. So butane is used for fuel and portable stoves, and also we are using in a cooking gas also with the mixed propane. Next, ethene. From the ethene we are getting alcohol. Alcohol in the sense we know in our real time example and day-to-day life we are looking forward the alcohol. So from that alcohol is extracted from the ethane. Ethane is also one of the organic compound. This ethane is also used in the polythene. We are using the polythene bags, polythene covers. In that product, the chemical mixed is ethene. Ethene is one of the organic compound. It is neither good nor bad. Then too we are using the polythene bags. So these are the few uses of homologous series. Now you come to know why we are studying homologous series, what is the purpose and what is the characteristics. Homologous stands for general formula and same functional group. From why we are combining into the general formula and the same functional group, in the sense it will be very easy to characterize the each organic compound. If it has the same chemical formula, means we can judge easily about, if you take one product, we can judge it easily, how that product will work, how that product will not work, we can easily judge by the help of this homologous series applications. So application in the sense, we are applying this homologous series in our daily life, like butane, ethane, propane, like that we are applying. So that's all about the homologous series. The homework for this week is, you have to write the homologous series for these three organic compounds. First one is butane, next one is pentane, the third one is hexane. You have to show the difference between butane to pentane, pentane to hexane, and post it in the comment section. If you are having any doubt, please comment in the comment section. We'll catch up in the next video. Thanks for watching.